Okay, are we doing it? Are we online? Are we on the internet? Are we using the computer? I am using the computer. Actually, I'm just gonna mute myself for a second. Doing loud things. I got my dirt beer because for these streams I am basically fueled by dirt beer. Okay. Yeah. So I did I do these like if you're not familiar, I do these like morning warm up videos sometimes. I like roll out of bed and just like yak about whatever's on my mind for 5 or 10 minutes depending on, you know, how chatty I feel. But I don't try to make it exceed 10 minutes. But anyway, so I had a little bit of a rant on Blue Sky earlier earlier this week, and it had to do with to-do lists. So I tried to do like a warm-up video about that, and I just didn't like how it went because I was conscientious about the amount of time that it would take for me to talk about it. And so I was like, you know, trying to keep, I was also kind of preoccupied with other stuff. I had some client work I was doing. So like I didn't really love it. So I just like decided not to post it. And so, but now that I'm streaming, it's a lot roomier. And I can like have, you know, if I'm going to talk about this for an hour, I don't know if I'm going to talk about this for an hour. I could talk about it for 2 hours. I could talk about it for half an hour. I don't know. But yeah, I don't feel like as sort of constrained by time. But so I'm just going to like, so what happened is, if you don't know, which I don't see any reason why you would unless you're like a fan, which, I mean, come on. But so I have this application server I call Intertwingler, and what it is basically it's not basically anything. What it is it's an application server, so you know it runs applications. It's a web application server, and the reason why I made it and the reason why it had to be made is because it enables me to write what I've been calling dense hypermedia. And dense hypermedia is just like little things, little bits of, you know, addressable information, and like lots and lots and lots of links going in and out of them, and like other characteristics, backlinks, and all so on and so forth. So like what Intertwingler does is it just sort of takes care of all the like crap work of dealing with like just dealing with that. Because like, you know, basic problems of like making web pages is like making things that are, you know, gonna respond to URLs and making them sure that they stick around, and there's like a bunch of that kind of thing that you like if you're like making an app on Rails, or you're, you know, you've got issues like, you know, like any kind of like, you know, you the way that you do something like Rails is you write a controller, and this is any MVC framework. You write a controller. The controller handles some subpath of the URL. It might be parameterized, so like different URL path segments mean, you know, different things, and then they like get looked up in a database, and then the database, like, you know, whatever you, so like, you know, you're typically doing something like you're doing something with SQL, and And, you know, so like you're making pages, you're doing things in SQL, and so everything that you're doing is like if you wanted to add a new kind of thing, a new kind of relation, it's like you got to go into the database and you got to write a table and then you got to define it. And then it's like if you want to do a thing, you got to like make a join and you got to add a thing. Like you got to do all this stuff. And I mean, for one, like I've been using graph databases for like a really long time instead of SQL, and I'm kind of at the point where I'm like sick of SQL, and I find it like to be a bit of a pain in the ass. Like every time I have to touch it now, compared to RDF, which is like breezy. And so like one of the things that Intertwingler does is it's got a bunch of like RDF like infra in it, and you can just like, you got some stuff, it'll like turn that into a web page, and then like if you want to like stick another thing on it, it'll just work. And so it's like it's amenable to doing web apps that I would say are like characteristically a pain in the ass to do, like with an ORM and then our MVC and so on and so forth. And so one of the things that that I made like 11 entire freaking years ago is like literally over like 11 and, you know, 2 weeks or something like that. No, 3 weeks at this point. 11 years, 3 weeks. Is this guy, which is the IBIS tool. This is like, wow, it's in this like third iteration right now, fourth, and at least the visuals. Yeah, third or fourth, something like that. But like this has been like plodding along for 11 years. Yeah, so I made it in like 2 weeks 11 years ago, and I just like the way that because it works, like it runs on like an SQL backend with an MVC framework, and it's just like too damn much code to be nimble enough to do anything useful with. And so this is not running on your Intertwingler. This is its own like janky prototype backend. I mean, there's all sorts of stuff that's still, I mean, like I just don't want to touch it yet because it's not ported. So anyway, I was like, I've been busy with all sorts of stuff this year, and so I've been sort of like trying to like sequester the time to like, okay, like finally port it over, and it was like a multi-step process. I had to like bifurcate the front end from the back end, and I had to like partition a bunch of stuff and like rearrange and refactor and rearrange all of the dependencies and blah 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 blah. And so after like an almost entire year, I mean, because like Intertwingler has been like more or less like ready to go since like the end of March of this year. And so like since the end of March and like, I don't know, like last week, I'm like, okay, like I'm going to do it. It's going to be done forever. You know, we can like jettison the friggin' janky prototype backend that this thing is running on, and like use it on the shiny new application server that I spent an absolute shitload of time working on. So I get to the last step and I discover this note. It is not clear at the time of this writing. Oh no, that's not the one. This note. While parameter registry offers quite a bit of control for parameter sets at the time of this writing, We're only interested in the simple single cardinality scalar parameters that decorate TFO functions. So you don't have to know about that. But when this behavior changes, this note will be removed. Yeah. So that's a note to I don't even know when the hell I wrote this. It would have been back in, I don't know, March or something like that. What if I said like, VC, what, info? How do I do this? Status? Whatever. It's old. And anyway, so I'm like, okay. And this would have been like last Saturday or something like that. I'm like, all right, what do I need to do to make this state of affairs go away? And the answer is over. Not you, stupid. The answer is over here. This is like, minus like the annotations. This is about a 48-point bullet list, to-do list of stuff that I need to actually do to make this thing go. And so it got me thinking about to-do lists in general. And the irony of all of this is that this is basically a to-do list. Like at its root, that's what this is. You have an issue, you respond to the issue with a position, and then, a candidate for like what to do about the issue, and then you respond to issue, or you respond to positions with arguments. So you just sort of like trundle along by generating all these things out, and it generates a topology that you can then compute over. And so on. So like at the core, that's sort of what this is. There's a bunch of other theory and a bunch of other stuff associated with it. I've done a bazillion videos on it, so I'm not going to get into like the actual details of it. But so the irony is like, if only I had this goddamn thing done, then I would be done, or I would have at least known upfront like that the note that I wrote to myself, that this damn, situation of this thing not being ready, I would have known because I would have had the thing. But I don't have the thing because I haven't made it yet. Or I have made it, but I haven't, gotten it to a point where it's like actually like not annoying enough to use on a regular basis. And so like it got me thinking like about to-do lists in general. And what's sort of funny about it is, so first of all, like this is org mode, okay, like it's an outliner, right? Like this is part of like just like the big to-do list that I have. And again, irony is this is a to-do list. So that was annoying. Where are we here? Yeah, anyway, so we'll just narrow that again because you don't need to see that other stuff if you want to see it. It's in the GitHub repository of Intertwingler. Yeah, okay. So yeah. Now, what did I want to say about to-do lists? So, like a to-do list, I was on Blue Sky and I wrote out like, okay, like what are my sort of major beefs with to-do lists? And one of them is like, you have to-do lists, like items sort of in the to-do list that are dependencies on like more than one thing. And then you have the things that, have more than one dependency. So you like break the like a straight hierarchy And I mean, yeah, you can kind of fudge it in org mode or whatever, but like, I don't want to have to think about the topological structure of the damn to-do list. Like, I want it to sort that out by itself. Like, I don't think I should have to think about that. Also, like any kind of prioritization or ordering, you know, like where the sequence of operations, like you should just be able to like compute that, you know, like like if you, for example, you know, like in the you know, mother of all demos, like if you go to like, you know, where are we here? I don't know if there's just like a path. I have to go and like dig it out of the video, but if I have to, I will. Where he like takes the shopping list and he turns it into like a path of, you know, where do I go? I don't want to dig it out because I'm sure I'll get dinged for copyright or some shit if I do that. But like, if you could just to, for instance, like tie the like the to-do list to a location, then you could just have the computer compute, you know, the priority list of the list for you. So the idea of having to have like having to prioritize stuff like by hand is, it's just silly. Like maybe, because the other thing too is like the combinatorial space is the permutation and that's the factorial. So like it gets very big even with a not very big number. Like if you had 5 things, that's 120 possible sequences of doing the 5 things in. And it's like, I don't want to have to think about that. Like the computer should do that. So that's, you know, that's one thing. Yeah, the planarity thing, like the actual structure, a hierarchical structure. So the order and the like having to force things into like a strict hierarchy, I don't like that. That's like just basic stuff. And then there's the like issue of like of when you don't even know like what the actual task is. And you know, you actually, the task is just figuring out what the task is. And again, this is part of like what this thing is for. Like a lot of this stuff isn't directly actionable, you know, or if it is actionable, it's just a candidate. It's like, do this. And then like, so if you have an idea, like this is the other thing too, is also you have an idea for something and you're like, actually not the greatest. But like you at least register the fact that you've had the idea, like it doesn't just disappear. Which brings me to another situation is like whenever there's other people involved, especially if you're like proposing to spend their money, like you want to be able to argue why. And again, like an ordinary to-do list. And again, like, you know, like there's project management software like Gantt charty stuff, which will, you know, resolve, you know, a directed graph of to-dos, but then like you still have to put the stuff in, like you still have to have done the computation elsewhere. Like you still have to have like figured out like, you know, what order, not order, but like you have to figure out like, you know, aspects of it that are not entirely obvious. And so it's like, well, where do you actually get that work done? Like, what is your substrate for that? Like, is it a whiteboard? Like, is it Post-its? Like, is it Miro? You know, I mean, Miro, God. I don't know if this is still the case, but Miro is just like pictures. Like, it does not have any like it doesn't have any like semantic structure at all in there. It is it's just a, yeah, it's just a freaking mess. I know this because I was working on a client. We actually had this like, good, interesting sort of model. I thought it was cool. It was, here, did I just do it right or did I not? Come on. All right. Here. Oh, I got moved. What the heck? Man, you guys suck at this. Hang on a second. No. Okay, you should be locked and not do that. This should be bigger, and I don't know why it's not. Oh, for fuck's sake. I'm just like, come on. Whatever. Yeah, so we had this sort of 2x2 space, and we did this thing where we put up these like little Miro post-its on this space, and I think like one of these axes was value and one of these axes was hard, like difficulty. I don't know how you, like, let's just, hearts or something like that. I don't know. And so the idea is it was a charrette, basically, exercise where you put the post-its like relative to each other, and it was like, how valuable is this thing versus how hard is it to do, and which the idea is sort of like the valuable easy stuff would be here, the value less hard stuff would be there, and then like but they would be topologically relative to each other, and I had to I wanted to at least take the coordinate data and actually like turn that into a graph structure based on that, and it didn't, like, it was like such a pain in the ass to do that. Like it was yeah, it was not fun. So I don't recommend that. Anyway, what else? Why is that even on there? I'm just gonna try to move stuff over here. Anyway, so where am I here? Go back to the. So yeah, I mean, aspects of to-do lists, like, there we go. Why am I over in the corner? Why is everything just not right? How did I even miss that? Thinking here. But yeah, so like in the first layer, you've got, your to-do list is kind of like a projection. It's like the only things that can like go on a to-do list are the things that like you are tasks that you need to do. Anything that is like more, and of course the dependency graph has to be a tree. Like it can't be two things going into one thing going into more than one thing. Like it can't be that kind of it can be one thing going into more than one thing because a tree can do that, but it can't be more than one thing going into one thing. So that's, a pain. What else? Then there's like, yeah, involving anybody else. So you've got, anytime you're like delegating, anytime you're sharing something, anytime you're delegating, you've got, issues of delegating. Obviously, you've got issues of partitioning tasks, that kind of thing. Tasks, a lot of tasks. So the other thing that I found too, one of the things that that really, where are we here? There. One of the things that really kind of spurred development on this was the idea that a goal, goals and tasks are separate. And so the other thing about a to-do list is a to-do list only considers tasks. It doesn't consider goals. And so like the goals are not part of, like, they're implicit in the task. Like, it's like, well, if it's a to-do list, you just know that it is, a thing. There's other things too, like repeatable procedures, recipes. There's bills of materials that a task involves. So like, if I need to build a house, well, I need lumber, don't I? And I need I guess we use screws now. We don't use nails anymore. That kind of thing. Like, and that's not even, that's like assuming you already know like the plans and what you're going to build and so on. So there's that aspect of it as well. God, what else? I mean, there's just so much to consider. Like, so you start with like the basic concept, that the familiar thing that everybody understands, which is a to-do list. Everybody understands a to-do list. Do people understand, hey, like if I'm going to write down a to-do list, there's like, is the to-do list actionable? And like when you go to, like, say for example, what's his face? The Getting Things Done guy, David something or whatever. He's like, oh, well, you gotta turn it into cranking widgets. You just gotta turn it in. He's like, and it's, yeah, you do have to turn it into cranking widgets, but like, how do you do that? Do you know? Like, do you know, like the process of turning a process, the meta process of turning a process into cranking widgets is actually tough. It's actually something that you need to think about. It's not something that it's like you just do. And it's kind of like a draw the rest of the fucking owl kind of situation, where, it's like, oh, like we did this thing, and it's just, all you got to do is you draw two circles and now you draw the rest of the owl. And it is, I mean, that's not helpful, right? Like, it's not actionable. And there's so much stuff like, I see Americans talk about this. Like, they'll have like a be something, like be whatever. And it's like, well, how do you do being whatever? Like, it's not actionable. It's not it's not something that you can do. Like, being something is not being a thing is not a thing to do. And, but this is like not considered. So it's like starting from the point of view of an individual person just trying to get stuff done. It's like, sure, over the set of things that I know and over the set of things that I'm already like, I know what priority they are. If it's going and getting things, like I can figure out the order of things that I go like and get. If I'm going to go to this store, I need to get these things, kind of that we can figure it out. But that's like the simplest, most elementary situation. And then it's like, okay, well then we got to get to the like how do we unpack a be something, kind of an assertion? How do we unpack that into actions that you can actually do? How do you do that? Well, you need workspace. You need something that'll help you do that. And I don't know, I guess like some people get therapists for that, but like, there's also the possibility that like you could just figure it out. Like, I mean, because again, everything that I do, like in my work, is trying to like articulate how to execute, like how to turn thoughts into actions is like a humongous part of what I do all day long. And like, I can't delegate that because that's my job. Like, I can't delegate that because, what would I be doing if I did? I would just be somebody's manager at that point. And so, like, again, going back to this thing, you got these red objects that they're issues. They're things in the world you want to do something about. So they're not even goals per se. They're just issues. Then you've got the positions, which is like, what do you want to do about it? And then you have arguments of like why or why not. And then like you might have more issues that arise from the issues and position, like they kind of cascade on each other. And so the next step with this thing, like once I get it ported over, is to like graduate issues, positions, and arguments into goals, tasks, and targets. And so like once an issue has been identified as a thing in the world and we actually want to do something about it, then we can sort of graduate that issue into a goal. And a goal, this is the other thing too, when you like look at the go and get your favorite like airport business book, self-helpy kind of thing, where like you get Drucker or whatever, and he's like, well, a goal is just a wish unless it's got a budget and a deadline, and it's got resources allocated to it, and when it's going to get done. Now, I don't know about you, but like when I find, at least, like dealing with situations where like the thing that you're dealing with is information, and the problem with information is like, even if like how much effort it's going to cost you to get a certain piece of information, you don't know like what the implications of that information are until you get it. And what that means is it's kind of like you get this information, you have to process it. That might trigger a need to get more information, which you also have to process, which might trigger a need to get more information, which you also have to process, and so on and so forth. And I think that like so it's like software exhibits this all the freaking time. Not exclusively software. There's other things that do it too. I think all kinds of creative endeavors do this all the time. Like they're because like it's effectively like you don't know the scope of, like you don't know how much effort it's going to take up front because you don't know how many things there are. And it's really just as simple as that. Like the quantity of things is unknown at the outset. And so obviously that's problematic if you're trying to like deliver stuff and get stuff to people that is worth more than it costs. But, and this is sort of the thing that has like really kind of, driven me over all of these years, is like, how do you take the to-do list, which is effectively a project plan, and wring out all of the uncertainty from it using the cheapest media available. And I think the cheapest media available is electrons in a computer. And we don't really have like, we're just sort of copying stuff a lot of the time. We are, when I look out at like even the most sophisticated, uh, um, project management software out there, it's copying paper a lot of the time. And it's like, okay, you take a Gantt chart, for instance. A Gantt chart is a technology is over a century old. It was actually made by a Polish guy, but the Anglo guy like got the actual name attached to it. But it was, and it was like in the 1870s, I think. And it made sense for civil engineering. It made sense for like surveying projects. It made sense for railroad projects, which is basically what surveying was all about. Road building, that kind of thing. There's a great book called Roads to Power by Joe Gildy, which talks about all of that. But the Gantt chart, like the way that you make a Gantt chart is you start at the end and then you work your way back. And you sort of think about all, like it's basically a tree at that point. And so I think you can't, I mean, this is sort of the issue, like again, with like waterfall and whatever, like the waterfall paper by Winston Royce in 1970, like the thrust of the paper was that don't do waterfall. Like that's what the paper says. If you read that paper, and the reason why is because there's all sorts of feedback that happens in the process. Now, presumably when you're, surveying and you're doing railroads and stuff like that, there's feedback, and building buildings or whatever, there's still feedback. But, you kind of stomp on the feedback because you can. And you also kind of have to, in a lot of sense. Like there are people who argue that you don't have to, but, in practice you have to. And so, but in software like that just doesn't work. If you say, well, we're just going to steamroll through this stuff, and it doesn't work. And you got to throw it out, and then you got to redo it. So there's feedback in the software development process, and other things, right? Like other things like, like movies, and novels, and movies are basically novels with extra bits attached, like. So, you say, for example, like you've got this story and like, you get all the way through and then like the story just doesn't work. And you're like, well, this happens all the time in movies. They even get to a point where they get to shooting and they're like, ugh, like this dialogue is dumb. Like this doesn't make sense or whatever. And it's just broken and it needs to be replaced. And it's kind of like one of those things that you you might have been able to understand. And the Bent Fleabberg book, How Big Things Get Done, he talks about, he's got two major case studies. He's got Frank Gehry and he's got Pixar. And what's interesting about these two entities is they are very good at delivering on time, on budget, and delivering a result that is like exceeds expectations for its performance. I mean, say what you will about Gehry buildings. I know some people really don't like them. I don't know. I find them. But put it this way: after reading that book, I was a hell of a lot more sympathetic to Gehry. Because like he's not like a freaking what's his face, the Utzorn or whatever, the Sydney Opera House guy, which was the counterexample in there. Because if you're doing a project, like what you've done is you've like made a promise to somebody that you will do, a certain thing, in a certain amount of time on a certain amount of money, and it's going to have this certain outcome. But the thing is that I think a lot of people don't take into account is like, it is up to you to to say what you're going to do. Like that is where you have your control. Is you can the content of what you promise is up to you. A lot of the time, you know, sometimes maybe somebody will be like hold a gun to your head and say you're doing this, you know, or else kind of thing. But a lot of the time, the outcome, you know, sorry, not the outcome, but the content of what you're promising people is under your control. And so you got to think, well, okay, like what am I going to promise people? And so like, you know, I would say like maybe 10 years ago. So like, here we're saying, so this thing, like one of the things that was like majorly influential, like the reason why I started looking at this. So the reason why I started looking at this was Engelbart. There was a salon, like a sort of, you know, Q&A or whatever the heck you want to call it. I mean, the guy was like 80 something at the time at Google in like 2009, where he's talking about structured argumentation. And of course, Engelbart's like, you know, well, I mean, he's been sort of steeped in this stuff. So he's talking about this thing called, he just throws out this thing called structured argumentation. And I'm like, huh, like what is that? And so I go and I look around and I just search around or whatever, and I find a couple of things. And like one of the things of structured argumentation is this thing called IBIS, where again, you've got three classes of entities. You've got the issues, you know, I'm going to try to find like, sure, here. So, you know, you got issues, thing in the world that needs something done about it, something, at least a decision. You got the position, which is, you know, what to do about it, which you could have multiple candidate positions for the same issue. Did I click on that? I didn't click on that. And then you've got arguments which either support or oppose the issue, or support or oppose the position. And again, this cascades, it builds up, and then like the positions can raise issues, the arguments can raise issues, the issues can raise issues, those can have positions, and then just it builds up into a network like the one that is on this screen. And so that would have been, 2009 that I was like looking into this stuff. I had this sort of idea way back for like what I was calling a project scaffold. And a project scaffold would have like these sort of three lobes to them. It was like the catalog, the activity, and the, I don't remember, there was something with lexicon, that's what it was. And the idea was it the lexicon? No, doesn't matter. It was a long time ago. We could, no, I don't want to say. Well, let's see. Why can I not? Why is, no. Now I'm like curious. Reference catalog activity composition. Oh, yeah. Okay. Composition pairing the form of the context. Yeah. Okay. Yeah. yeah. So the activity was so this is, where is this dating? 2008. So I had this like bright idea in 2008 to make this thing called a project scaffold. And so like for my projects, so the idea actually, I mean, so this IBIS tool effectively plays the role of the context and the form. You got to understand like Alexander's notes on the synthesis of form to understand this. Because in his sort of conceptualization, you've got this, the idea is you've got the form or the context, which is all the parts that you don't change. And then you have the form, which is the part that fits the context. So that's the thing that you do change. And so in the case of like a software project, the form would be the code. Including the testings code also. It's kind of, you know, weird recursive stuff in there. But so the whole reason though why I got on this kick was that like back in, God, it would have been 2006, 07 or something like that. So, you know, a couple, you know, years before I wrote this bit about the project scaffold, was I was working at in a lab at a you know, like a cybersecurity company, an antivirus company, and our job was to map out the entire internet, looking for stuff. I guess you would just use like gray noise or something like that for this now, but the idea was you scan the entire internet looking for hosts sending email. But it's like, if we could determine that it was on a cable modem subnet, then like, you know, clearly that you're not supposed to be sending SMTP straight out of a cable modem. Certainly not to anything that's actually going to receive stuff. So anyway, this was all novel stuff, and like nobody had made one of these things yet. And I mean, there was somebody sort of, other people kind of working on it at the time. But you know, it was novel work, and still it was kind of like done as if like it was just, you're making like an everyday boring web app or something like that. Like it was not given the sort of serious treatment of being something that, you know, that was like a novel, unexplored kind of like, how the heck are we even going to do this piece of software? Nevertheless, of course, like, you know, as bosses do, like they want, how long is it going to take? They want to know how long, they want estimates. And so I got really, really focused on like what it would take to make an accurate estimate. And I came up with this technique that I called behavior sheets. And what a behavior sheet is like, let's say you've got a module of software that you want to write. Like there's something that you want to do. You get an outliner. It doesn't, I mean, it could be, you know, anything, an outliner like org mode or whatever. And then you just start writing out, and this is important, behavior, like specific prescriptions and proscriptions about like what the software must and must not do. And that's not to do with features. That is, must do this, must not do that. It's like you force your language to talk about like what it, like how it should behave. And you might want to indent. So like if there's a condition, you indent and whatever. So, but it's not pseudocode. It's not, it's like, it's still English. And you write out these behavior sheets, and it gets into the hundreds, you know, like it's actually kind of funny because this is very similar to what you're looking at in the left half of the screen here. It's very similar to a behavior sheet. It's not quite as granular as one. Like it would have to be more. This is just a boring old to-do list. But so what I found though is, first of all, the behavior sheets did a absolutely impeccable job of saying how long it was going to take to write the code. like the estimates that a behavior sheet produces, what you do with the behavior sheet is you bang out, you go through and you just say, oh, you must do this, must not do that, must do this, must not do that. If this, must do this, must not, blah, 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 blah. You just go until you've like wrung out like every possible source of surprise that might be waiting for you, which of course is the thing that keeps, that is what you would need to make an estimate that was accurate. And so, it would do that. But the caveat is that if I started a behavior sheet at 9 a.m. on Monday morning, I could tell you by lunchtime on Wednesday that the module of code would be complete by end of day Friday. So like it took as long to do the behavior sheet as it did to write the code. So it was totally useless for forecasting because, what the boss wants is he wants to know how long it's going to take quickly. But what it did on the plus side was it organized activity. So it actually probably made the code, like the writing of the code, take a lot less time than it otherwise would, because you would be hitting all of these impediments, barriers, walls, surprises, basically. Oh, I didn't know that there was a bug in this library. Oh, I didn't know that, this freaking, we forgot, we didn't consider this, thing. We got to rip everything apart and, do it all over again. Oh, we have to change the database to, we got to do these things that we didn't consider. And it's like, well, what does the behavior sheet do? Is it figures all that stuff out in advance. It's not quick, but it does it. So I was like, okay, that's really interesting. Like, there is absolutely value in this, but, and it reliably creates accurate estimates of cost. It just costs basically like, in proportion to the thing that it's being made. And, that, like, so I was like, well, I'm not going to throw the freaking baby out with the bathwater, but like, let's think about this for a bit, right? Like, the question is, like, if this is what it takes to create an accurate effort estimate, is you got to sit down and like bash it out. You need to have the green light to actually execute the the research needed. Well, I don't know. I think it would have been around like 2014 when, I don't know. I mean, like, just like anybody else, like I had read like, Nassim Taleb, Fat Tales, whatever. I think that is about the sum of his sort of, contribution. I think you can find a lot kinder and gentler people, nowadays, than him. So, you don't have to really listen to him anymore. But at the time, it was sort of revelatory. And of course, what a fat tail does is it has no variance. And so I think it was around 2014 that I convinced myself that that there had, like, if the problem was, how do we deliver value that is more valuable than what it costs to deliver the value? Like, how do we do that if it's so costly to figure out, like, to actually do, a cost, if the cost estimate is so costly, then you need a cost estimate for the 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 cost, like, so, like, that, obviously is silly. And so the question sort of, was to me is like, well, how do you do the job of delivering more value than you cost without having to try to come up with the cost and try to establish the cost without the risk. That was the other thing too, is and how do you do that? And so I don't know, like I wrote this like 8,000 word essay back in 2014. And I can't remember if I ever actually if I came up with it then. I don't know. I might have. It's life after forecasting. I don't remember if that was the time, but like the idea. Eventually, like it took like sort of years to really settle, and I did this one like sort of timing test. Like I was going to do like a talk about it back in 2021, sort of when I did the timing test for it. But the idea is like, well, you can, and you can control resources in under a fat tail scenario where there's no variance. Because this is the thing, like the way that you do, the reason why a time estimate, like an additive time estimate would work, and the additive is important, I'll get to that in a second. The reason why it works is if the process is thin-tailed, and the reason why so like my girlfriend from like 2013 to like just the beginning of the pandemic lockdown is a hairdresser. And what was very interesting to me was that when she booked a hairdressing client to do their hair, she could reliably get in and out in an hour, like, delta of like 7 minutes or something like that. It was very, very accurate. On either side. So that was like absolutely, like, that is a thin-tailed process. And so you could do like book an hour plus minus 7 minutes, or whatever it ended up being. It was very reliable, and it almost never went over. And, and it was, and when she had to do like more complicated stuff, she would pad more. So like if she had to do like a really hectic, like, repair hair dye job or whatever the heck, where the client would be there all day kind of thing, like, but the other thing too is also she would charge so much money that like it didn't matter, like she didn't need to book anybody else that day kind of a thing. So I was like, that's like really interesting. It's like how reliable your job is. And I mean, like, and I can think of like people who, in my life who've like hired, contractors to build a deck or, whatever the hell. And it was, again, like they would do, the design overhead of their job, of the thing that they needed to do, was like, okay, we'll get the measurements. Okay. Yeah. We're going to do this basic strategy of like how it's going to stand up, and, and this is the parts that we're going to need to make it strong enough. And, and then they just add it up with a freaking calculator, not even a spreadsheet. They don't even need a spreadsheet. They just add it up on a freaking pocket calculator, and a piece of legal pad, whatever. And they can get you an accurate estimate in just a few minutes. And it's like, okay, yeah, okay, so cool. Like there's not, this is not a reno. A reno is a completely different story, but build a new build kind of thing. And it was like, yeah, like genuinely reliable. So I'm like, well, why don't we have that for software? Like, why do we struggle with that so much? And I gotta like hand it to Carlos Bueno, the guy who invented the term, among other things, invented the term full stack developer. He did this thing where he was talking about estimates, but he was talking about estimates like how many data centers does Google have, or you know, how much whatever, how much wattage or compute does Google use, or something like that was like the question. So what he was saying was like, if you add and multiply from zero, like when you're trying to estimate stuff, like what ends up happening is that you will be wrong in the, like the errors will be wrong in the direction that you don't want, and they tend to like accumulate. Whereas if you subtract, you start with a number and then you subtract and divide, the errors get smaller, and the error typically is in the direction that's fine, right? And so, and I'm like, well, why the hell don't we estimate projects that way? And you know, why, like when I think about all of the shit that I have read over decades about estimating software effort, every single one of them adds up from zero. Every single one. I have not seen a single method that starts with a number and whittles it down. I've only seen ones that start from zero and add up or multiply upwards. So like, why are we doing that? If that methodology is fundamentally wrong, why is that the only one considered? That seems to be a massive oversight. That seems to be an absolute, complete clown show. So yeah, real serious question there. But then like methodologically, the question of like, how do you do that? What do you do? What number do you start with? And I think that, you know, software in particular has a value per run. Like any piece of software, any as long as it runs in the first place, any piece of software has like, you know, and of course, obviously in production, every piece of software has a value per run. And, you know, you can just put it, again, like any like module, like you can get them pretty small too. You can say like, every time this function is run, like, what's that worth? And, you know, that is a number that you can start with. You can figure that out. You know, and you can say like, oh, like it amortizes, you know, it could be like a net value per run. So like, how much do you have to spend? What is the cost of maintaining, like, you know, updating this thing and fixing bugs in it, and, you know, getting performance, you know, better or whatever. Like, what are the actual sort of overheads of that? How many times have I switched this freaking thing and it's not switched? Okay, did we do that? Right. So yeah, value per run. And then you know, you give it like an arbitrary, like, you know, interval. You say 5 years or whatever. I don't know, like how long does it take before it to run? And the thing about it too is like some software gets run billions and billions and billions, trillions possibly times. Like because you can get them pretty small. Again, you can, you know, how often is the, you know, the like jump instruction, you know, on an Intel or processor, you know, run, you know, how many billions of times a second per computer is it run? Like, you know, then times how many computers are there? How many? Yeah. Anyway, but we don't need to speculate on that. But you know, it's obviously pretty valuable. But you know, how? So like, you start with that number, and then you say, okay, like, you know, you can, like, there's standard accounting stuff that'll give you, or financial accounting stuff that'll give you like a depreciation measure on that over time, like, you know, what's it going to be worth in however many years, and then you like just subtract all of the things, and then you know, you can like add some sort of like speculative wild card values on that. You can get a pretty decent discount on, like, you know, so then you can actually say like, well, how much is it to, you know, how much, like, is it going to cost, like, can we do it in less time, money, whatever, like, because that's a different question then how long is it going to take and how much is it going to cost? And of course, how long is it going to take? Until AI came along, how long is it going to take and how much is it going to cost? We're like basically, a linear relation between the questions. Now, it's hard to say because the cost might be way more than the time, kind of a thing. But so anyway, that's sort of the big idea of that is like, you figure out a value. But then again, you need a substrate. You need something that's going to do the job of that, of figuring that, of helping you figure that out. Because like, I guarantee you, like a spreadsheet is not going to cut that. It's not going to do a good job of that. Because spreadsheets do not model a directed graph very well. Let me tell you, I have tried, and it is not good. So yeah, directed graphs are good. Spreadsheets are limited, but I think that, and then what I was talking about to-do lists, but there's like so much more to it, right? Like there's like trying to determine what the task even is, trying to determine like, what are the goals, what are the things that are actually the problem, what are the issues, what like there's this entire sort of universe of around a to-do list that is not modeled, and it is not rendered computable. It is not like just even stuff like the rationale. Why are we doing this? Why are we spending this money? Why should we bother? How are you going to explain this to somebody? When you go to a stakeholder and you're saying, well, we got to do this weird thing, and they're like, why? And you're like, well, here's the time that you said, you wanted this thing. This is the dollar value that we attached to that and you signed off on. This is a bunch of work that we did that, resulted in, a bunch of decisions being made. So in order to get the thing that you want, like again, you go back to, is that right? One. This one. It shows that I've changed the thing in the corner of my screen, but of course there's some freaking Linux mess up. Anyway, so yeah, like, these green guys are like potentially they're things to do. That's an actionable in this case. The thing about the IBIS stuff is that like a position is not necessarily actionable, which is why I needed a sort of extra process model layer on here. It is not implemented yet, but god damn it. That was what I was going to do this week. That's what this gigantor freaking to-do list was about. That's what this note was about. God damn it. But the last step in the whole friggin' thing, and then I find this note. Well, params registry offers quite a bit of control for parameter sets. At the time of this writing, we are only interested in the simple single Cardinality scalar parameters that decorate TFO function entities. When this behavior changes, this note will be removed. Frickin' hell. See, if that note was not in the source code, and instead it was in a tool like this, then I would be able to have seen it. And wouldn't that be awfully nice to just, I don't know, have the version control or something like that, just plunk that in there. But no, we don't have that because I haven't made it yet. But yeah, so I guess the thing is like, when it comes to to-do lists, you have the combinatorics of the friggin' thing itself, assuming, you don't have any other like way of like disambiguating and fixing the frickin' what's it called? The task prioritization. The reason why you're doing the task is not there on the to-do list. It's implicit. You don't have an implicit way of partitioning or delegating. You don't, like, the structure has to be strictly hierarchical. There's no way in ascribing things like values. There's no way of ascribing things like locations. Like, you've got to do that all by hand. There's no way of doing like any kind of contextualizing information. Again, you got to do that all by hand. Anything to do with like sort of rationale, again, because the goal is not on the thing. So rationale gets lost. Like, why am I doing any of this stuff other than like to finish it? But like, why? If I had to justify everything, like why the spend, justify this to somebody, forget it. So yeah, you've got your colleagues, your stakeholders, you've got like, and then all of this other stuff, that sort of ancillary stuff that you've got evidentiary stuff, you've got just annotations of things that like have nothing to do with, like, they're not, they're kind of inert annotations. Again, that's going on here, but it's not there yet because this back end is freaking toast, cooked. So there's a zillion freaking things. But all I gotta say is when this to-do list, thankfully, again, like I said, we got to the last step in this freaking port process where like the back end of this thing goes bye-bye. The second this to-do list is done, this thing gets moved over to Intertwingler. It's going to be freaking glorious when it does. I'm going to have a funeral for the back end of this prototype when I'm done. I don't know. It's kind of like when you flush a goldfish down the toilet or something like that. But when this is done, there's going to be a celebration. And there's going to be a whole bunch. The PM ontology. Okay, I'm going to show that quickly. Is that even on here? It is. Okay. So I first cut of this 2009, July 22nd, 2009. I don't even know. But anyway, this ontology has been sitting around waiting for this tool to get ported to something that can actually handle that ontology without having to basically like write a whole extra app on top of it, which is basically what I had to do. So that is like the first step. Well, first I'm going to take like a week off and just like chill, because like I've been working on this forever. I did not realize like just how much of a freaking milestone this was. Like, I have always, like, this thing is always like, I made this thing back in 2013 to test a technical thing, and then it was like, this is actually kind of useful. And then it was like, like, I should like add stuff to it. And then it was like, like, it's too much effort to add stuff to it because it's just like the libraries underneath it, like the RDF frameworks, are just not capable of handling it, like, so basically you gotta like, because there's no reasoners, you're gonna hand code like all of the inferencing and stuff like that. And it's just like, I was just sick of it. I'm like, I'm not gonna do it. I'm gonna wait until I can find something, a better, piece of info for it. And I managed to do that. I did that last year. I got a grant for it. I made Intertwingler. It took me an extra 6 months on top of that to get to it, the point that it came in. The rest of the year, end of March. So I had something else I had to do from the end of March through to the end of like July or something like that. Oh, like, there was something other thing that jumped in there as well. And then I've had like client stuff and marketing stuff that I've had to deal with. And anyway, it's Intertwingler is there's still a whole shitload of work to do, but it's like, at least it has worked since end of March of this year. there's still a lot more to do, but like having this thing ported over will be motivation for me to actually like move on a bunch of stuff for it. And so that's good. But yeah, anyway, so I think that is about it for me here. Yeah, because it is 22:47, and I am going to shut things down and veg out until I go to sleep. So, I'm gonna finish my coffee.